All right, we're going to continue working on the graphs of a quadratic function, but this time we're going to add an extension, the plus c part. So a will never be 0, but now we'll have a number here that is non-zero. So don't forget, our standard form has 3 terms in it. So right now the b is equal to 0. So this component of it will be gone, but the a and the c will not be 0. So we're asking the question today, how does this quadratic function compare with just the simple y equals ax squared? And to do that, what we're going to do is graph several graphs. So make sure that you've written this down, pause the video, and get your graph ready. On this side, we're going to make tables, so just leave the space for that, and then we'll get started. All right, so you have written this down, and now we're going to begin by graphing several functions: y equals x squared, y equals negative x squared, y equals x squared plus 3, and y equals x squared minus 3. We're actually going to do it all in the same graph, and that way we can compare the differences in them. I would suggest using different colors so that you can distinguish the different graphs. So again, starting with y equals x squared, I'm just going to make a simple table of values. So and I'll do a horizontal table this time and just plug numbers in my head. So negative 2 for x, plugging it in, you square negative 2, you get 4. Negative 1, if you square that, plug that in for x, square it, you get positive 1. Plug in 0, 0 squared is 0. Plug in, let's do 1. Plug in 1, 1 squared is 1. And then plug in 2, and 2 squared is 4. Okay, so that's how we get our y values, and now we graph all of those points. Negative 2, 4. Negative 1, 1. The origin, and then all the symmetry points. Remember, I can just go across the symmetry points. So this is the vertex, this is my turning point, and then this is 2 units from my axis of symmetry, so my matching point, which is 2, 4, is right here. All right, so I'm going to go ahead and sketch those in. I'll use my pencil for that one. So that's my first color. Turn at the origin. All right, next I'm going to graph y equals negative x squared. I do want you to realize that that negative outside is the same thing as multiplying by negative 1. So I'm just going to make that a negative 1 so I can remember that. Remember, in order of operations, when we plug in a number, we're going to square it first and then do multiplication. So square, then multiply. All right, so x and y. And then we choose x's, so negative 2. Right? I already know what happens when I square it. I get 4. But now I have to multiply it by negative 1. That gives me a negative 4. Oops, let me break this up. Negative 4. Then plug in negative 1. Square that, I get 1, but multiply by negative 1 is negative 1. Okay, 0 is easy. That's just going to give me 0. Plug in 1. 1 squared is 1, but then multiply by negative 1. And I get negative 1. And then finally 2. If I square that, I get 4. Multiplied by negative 1, I get negative 4. All right, so I'll graph all those I'll use a red pen for that. And then, so negative 2, negative 4, negative 2, negative 4, negative 1, negative 1, 0, 0, 1, negative 1. So there's that balancing. You can see that turning, and 2, negative 4. Okay, so equal distance. The partners are always equal distance across the axis of symmetry. And then we'll just connect those up. All right, so how do these two graphs compare? Well, they're almost identical, right? They're just, one is a flip of the other. So when I have this negative value in front of it, I get a parabola that opens down. And so let me just write that. It's opens down. Okay, and then this one opens up. Just make little notes about things that happen. All right, so what if I have y equals x squared plus 3? So I'm going to plug a number in, square it, then add 3. Make a table. Okay, so x's, and then y's. All right, I'm just going to keep plugging in those same numbers. So -2, -1, 0, 1, and 2. All right, so first square your number. -2 squared, that's +4. Add 3 to that, that's 7. -1, square it is +1. Add 3, I get 4. 0. 0 squared is 0, but I'm adding 3 to that, so that's 3. 1 squared, 1 plus 3 is 4. And then 2 squared is 4 plus 3 is 7. So you can see that balance, right? 7, 7, 4, 4, and then 3. So this must be the turning point. So that'll be our vertex. And I think I'll use purple for this one. So -2 comma 7, -2, 1, 2, 3, 4, 5, 6, 7. So I'm all the way up here in my big idea section. That's okay. And then I'm going to graph -1 comma 4. -1, 1, 2, 3, 4. And then 0, 3, 0, 1, 2, 3. 1 comma 4. 1, 1, 2, 3, 4. Okay, so it looks like the same kind of turning, so same turning here. And then 2, 7, 2, x equals 2, 1, 2, 3, 4, 5, 6, 7. There it is. All right, so here's my parabola now. So it's the same thing as this one, just pushed up. And notice that the origin, which was my vertex on the first parabola, is now at 3. This point is now moved up 3. This point has moved up 3. And how about this one? 1, 2, 3. Yeah, both of these have moved up 3 units. So adding 3 takes the original graph and just shifts it up. That's called a vertical translation. So we're moving that graph up. So this is moving up 3. It was y equals x squared up 3 units. Okay, and then one more. So what do you think will happen when we graph y equals x squared minus 3? Okay, well, let's give it a shot and see if your idea comes to pass. So x squared minus 3. I'm going to stick with those same input values and make a table. So -2, -1, 0, 1, and 2. All right, so first square your number, then subtract 3. So -2 squared is 4, minus 3 is 1. -1. -1 squared is 1, take away 3 is -2. 0 squared is 0, take away 3 is -3. And then plug in 1. 1 squared is 1, minus 3 is -2, and then 2 squared is 4, minus 3 is 1. All right, so I know I did that quickly, but so a lot of mental math in that. All right, let's plot those ordered pairs. And let's see, what do I have? I have a blue pen left, I'll use that. All right, so -2, 1, -2, comma, oops, let me say that again. -2, comma 1. It's right here. -1, -2, -1, 1, 2, 0, -3, 0, 1, 2, 3, 1, -2, x equals 1, and then -2, and then 2, comma 1, x equals 2, comma 1. There it is. Is it what you thought would happen? So we're taking the y equals x squared graph, and look what happened to each point on it. The vertex went down 1, 2, 3. These 2 points went down 1, 2, 3. and these 2 points went down 1, 2, 3. So if you thought that the whole graph would shift down 3, you were correct. The y equals x squared graph went down 3 units. Let's write that. It moves the y equals x squared graph down 3. All right. So a couple of things just to quickly summarize would be that, let me start with, I'm going to do a little summary here. Y equals ax squared plus c. So a little summary. So c is the amount the graph moves up or down. So if you learn to quickly graph y equals x squared, then all of these graphs you can quickly graph just by moving the points the right amount, up or down. Another thing to mention is that we did get the graph to flip, the red graph, when the number in front was a negative. So when the value of a is negative, the graph opens down. So a less than 0, the graph opens down. But when a is positive or greater than 0, the graph will open up. All right, so opening up means that the arrows are pointed up. Opening down, the arrows on the ends are pointed down. Okay? All right, so we're going to graph a couple functions and then compare them to y equals x squared. And so let's practice just taking a guess at what you think will happen. We'll start with this one. Okay, and by the way, so you want to be able to graph really quickly. So I'm going to use this graph and we're going to compare it to y equals x squared. So I will make a table of values just to confirm my points. But because we're going to be graphing y equals x squared so often, it's going to be helpful if you can quickly graph that. Know the 5 key points that you're graphing. So let's just do an observation, right? So when we graph it, we're at the origin as our vertex. Then I go up 1, right 1. Then I go up, so I go to the right 1, up 1. Then I go to the right 1, up. How much? 3. So there's sort of that balance there. So they're balanced on each side. And then these 2 points, I go to the right one each time to get to it, but this one I go up 1, and then this one is up a total of 4 from the x-axis. So just a quick way to graph. Okay, so I'm going to draw my axes. Okay, so let's graph the original one at the origin. Then I'm going to go up 1, right 1 for that first point, and then I find its partner on the other side. Then I go to the right 2 and up 4. So these points are 3 away, right, vertically, but from the x-axis I'm 4 away. And then find its partner on the other side. This is 2 units, 2 units, so there's that nice balance. So this is the graph y equals x squared. So we're going to graph that over and over again. You want to get good at that. All right, so let's graph this one. What do you think will happen? All right, let's check that out. So I'm going to make a table of values. And plug it in. Square the number first. So 4, negative 2 squared is 4. Take away 5 is negative 1. Negative 1 squared is 1. Take away 5 is negative 4. Okay, 0 squared is 0, minus 5 is negative 5. 1 squared is 1, minus 5 is negative 4, and you can see that balance happening, so guess what's going to happen here? This is going to be negative 1. It's going to match. All right, so let's plot those points. Use a new color. So 0, negative 5. Right here, make my graph a little bit, my axis a little bit longer. Okay, 0, negative 5 is going to be my turning point. So look at this point, 1, 2, 3, 4, 5, it moved down 5 units. All right, how about negative 2, negative 1? Negative 1, negative 4, 2, 3, 4. And then the matching points, 1, negative 4, and 2, negative 1. There it is. And when we compare this, the difference, it's the exact same shape, just everything shifted down 5 units. Okay, so same shape. But we moved all points down 5. Okay, just count it. 1, 2, 3, 4, 5. So this is shifting the vertex down 5 points, right? Okay, so let's do another graph. Okay, so B. I do have to add 2 more graphs to fit in. So y equals negative x squared. All right, so what do you think is going to happen with that negative? What do you think will happen with the plus 3? And then the last graph we're going to do is y equals 2x squared minus 1. And for each one, I am going to build a table just to get good practice with figuring out how to get those points, because I don't know that you are ready to just graph this freestyle. All right, so I'm going to plug in all my key points, negative 2, negative 1, 0, 1, 2. All right, so remember what this means. I'm going to multiply by negative 1 here. I'm going to put it in there. So first I square the number, then I multiply, then I add. That's order of operations. Remember PEMDAS? Exponents, multiplication, division, addition, subtraction. That's the order. So I'm going to square negative 2. Negative 2 times negative 2 is 4. Then multiply by negative 1, negative 4. Then add 3. Negative 4 plus 3 is negative 1. Okay, now repeat with negative 1. Square it. That's 1. Multiply it by negative 1. We get negative 1. Add 3. That's 2. Okay, 0 is really easy because when you put 0 here, you just zero this term out. So that leaves me with 3. Okay, plug in 1. Square it. That's 1. Multiply by negative 1 is negative 1. Add 3 is 2. Do you see what's happening? Balance, right? So negative 1. All right, so let's plot those points and the y equals x squared. All right, start with y equals x squared. We start at the origin, we go to the right 1 and up 1, and then balance. And then we go to the right 2 on the x-axis and up 4, because that's 2 squared, 4. 2, 1, 2, 3, 4. So, and then find its matching partner over here. So there's y equals x squared. All right, let's graph this one. I'll use blue. All right, so negative 2, negative 1, negative 1, positive 2, 0, 3, 1, 2, 1, comma 2, 2, comma negative 1. Okay, so definitely has that shape. Turns at 0, 3. Okay, put arrows on the end. All right, so what happened? Okay, so notice that there's a difference in height of 3. The new graph is 3 up. There's the plus 3. It's also a flip. That's the negative 1. It opens it down. So it is up 3 units and flipped. Okay, all right, one last graph. Let's make a table. All right, y equals 2x squared minus 1. I'm going to plug in the same values, negative 2, negative 1, 0, 1, and 2. All right, square, then multiply by 2, then subtract 1. So square your number first. So negative 2, square it, 4, times it by 2, 8, subtract 1, 7. Square the number, that gives us 1. Multiply by 2, that's 2. Subtract 1 is 1. Okay, 0, remember, that just plugs this 0, and so that leaves us with negative 1. 1 squared is 1 times 2 is 2, subtract 1 is 1. You can see that balance happening, so guess what? 2 is going to give us 7 as well. All right, you get really fast, you start to see patterns happening and makes things go really well. All right, I see a lot of high numbers, so what I'm going to do is move my x-axis down so I can graph it. So I'm just going to leave it a little bit lower. All right, now remember we're going to start with y equals x squared. So 0, 0, 1, comma 1, 2, comma 4. Those are the 3 key points, and then we match them up over here. There's the balance, so balance point, and then a balance point, and there's our parabola. This is y equals x squared. Okay, don't forget what this is, y equals x squared, all right? Okay, now let's graph y equals 2x squared minus 1. First point, negative 2, comma 7. Negative 2, 1, 2, 3, 4, 5, 6, 7. Oh, I'm using a new color, purple. Negative 1, comma 1, right there. 0, negative 1. 1, comma 1, right there. And 2, comma 7. 2, 1, 2, 3, 4, 5, 6, 7. There we go. All right, so it still looks like a parabola, but a little bit different. Okay, so something else happened. It's changed its shape. Notice it got a little bit, that those 2 points, normally the first 2 points that come off the vertex are only 1 unit up, 1 unit right, 1 unit right, 1 unit down. So it's just a 1-to-1 relationship. But now look at, when I go 1 right, I have to go 2 up. So I've kind of stretched it up. And so this is going to be a more narrow parabola. It's going to rise faster than the other one. So it's just what we say is it's more narrow, and that's because we're multiplying by 2 here instead of a 1 or a negative 1. Okay, so another thing that we see happen, that minus 1, you can see that the vertex shifted down 1 unit. So we've got the shifting down and then something called a stretch. It's been stretched, it's more narrow. So I'll just say it in that sense. So this graph is more narrow, and the vertex is down 1 unit. Okay, all right, so we've done our comparisons, and now it's time for you to practice.